Welcome to tonight's video on the 6 trigonometric functions and how to find sine, cosine, tangent, and cosecant, secant, cotangent of an angle. So there are 6 trig functions. We've already touched on the first 3, the sine, cosine, tangent, the whole SOHCAHTOA. And if you notice the other 3, the cosecant, secant, and cotangent, those are reciprocals of the other one. So this cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. And the cotangent is reciprocal of the tangent. So instead of opposite over hypotenuse, it's hypotenuse over opposite for cosecant. Instead of adjacent over hypotenuse, for secant, it's hypotenuse over adjacent. And for cotangent, instead of opposite over adjacent, it's adjacent over opposite. So in a problem like this, where you're given a right triangle and you want to find the 6 trigonometric functions of theta, the first thing you need to do is find this missing side here, and you can do the Pythagorean theorem. And when you do the Pythagorean theorem, you should get that it's 12. So this missing side is 12. So now, based on the theta here, the sine is opposite over hypotenuse, which is 16 over 20, which reduces to 4/5. You want to leave it as a fraction. You don't want to make it a decimal. And then the cosecant is just 20 over 16, hypotenuse over opposite, which reduces to 5/4. So notice they're the reciprocals. Cosine, adjacent over hypotenuse, so 12 over 20, which reduces to 3/5. The secant is hypotenuse over adjacent, 20 over 12, which is 5/3. Tangent is opposite over adjacent, so 16 over 12, which is 4/3, and cotangent would just be adjacent over opposite, which is 3/4. All right, I'll let you do number 2 on your own, and then you can check your answer. Now, if we're applying these ratios to a 45-45-90 or a 30-60-90, sine 45, you can look from either one of the two 45-degree angles. It doesn't matter. It's going to be the same. So 45, we'll use this one. So sine is opposite over hypotenuse. So notice when you reduce, the a's cancel out. You're left with 1 over rad 2, which when you rationalize becomes rad 2 over 2. Cosine 45, you go adjacent over hypotenuse, which is the same. It's a over a rad 2. So it's also rad 2 over 2. And it makes sense because the adjacent and opposite are the same in a 45-45-90. So tangent, opposite over adjacent, a over a is just 1. Now for the cosecant, if you go hypotenuse over opposite, you're going a rad 2 over a. So you just get rad 2. Same with the secant, because you go hypotenuse over adjacent. And then the cotangent, it's still a over a, so it's still 1. Now applying this to a triangle with a hypotenuse of 1, remember with a hypotenuse of 1, this is rad 2 over 2, and this is rad 2 over 2, as we did previously. So the sine is just opposite over hypotenuse, so it's rad 2 over 2 over 1, so it's rad 2 over 2. So notice it's the same as what we got up there. Same with the cosine, because it's adjacent over hypotenuse. The tangent is rad 2 over 2 divided by rad 2 over 2, which is 1. The cosecant would be the reciprocal of 1 over rad 2 over 2. Well, if you notice, when you do that, that's the same as saying 1 times 2 over rad 2, which is 2 over rad 2. And then you rationalize, and you get 2 rad 2 over 2, and the 2's cancel out. So that's the cosecant and the secant. They're the same. Notice it matches up there. And the cotangent is rad 2 over 2 divided by rad 2 over 2, which is 1. So notice it holds true regardless of what the hypotenuse is or the sides are. In any 45, 45, 90, these ratios will be true for sine, cosine, tangent, no matter what the sides are. So let's look at this in terms of a 30, 60, 90. So sine for 30, 60, 90, opposite over hypotenuse. So a over 2a is going to give you 1/2. Cosine 30, so you have a rad 3 over 2a. So it's going to give you rad 3 over 2. Tangent, you have a over a rad 3, which gives you 1 over rad 3, which rationalizes to rad 3 over 3. Cosecant, remember, is just the reciprocal of the sine, so it's 2. Secant is the reciprocal of the cosine, so that's 2 over rad 3, which makes it 2 rad 3 over 3. And then the cotangent is the reciprocal of the tangent. So instead of flipping this one and having to rationalize, notice it was a over a rad 3, so now it's just a rad 3 over a, which is going to give you rad 3. Sine of 60, so now you look at the 60 degree and you go a rad 3 over 2a, so that is rad 3 over 2. So notice sine of 60 is the same as cosine of 30 because you're using the same sides. So that means cosine 60 and sine 30 will be the same because cosine 60 is a over 2a, which is 1/2. And that means tangent 60 will be the same as cotangent 30, which is rad 3, because notice you're going opposite over hypotenuse, so a rad 3 over a. And then the cosecant of 60, the reciprocal of rad 3 over 2 is 2 rad 3 over 3. The secant 60, the reciprocal of 1/2, is 2. And the cotangent 60, well, the reciprocal of rad 3 is rad 3 over 3. Now, just like we did with the 45, 45, 90, putting this in terms with a hypotenuse of 1, remember this is 1/2, and this is rad 3 over 2, going back to when we did that previously. So the sine of 30 would just be 1/2 over 1, or 1/2. Cosine 30 would be rad 3 over 2. Tangent 30 would be 1/2 over rad 3 over 2. So 1/2 times 2 over rad 3. The 2's cancel out. And when you rationalize, you get rad 3 over 3. Cosecant 30, taking the reciprocal of, so instead you go 1 over 1/2. So 1 over 1/2 is going to give you 1 times 2, which is 2. The secant of 30, so notice you go hypotenuse over adjacent. So 1 over rad 3 over 2 is the same as multiplying 1 times 2 over rad 3. So it gives you 2 rad 3 over 3. And the cotangent, if you go rad 3 over 2 divided by 1/2, it gives you rad 3 over 2 times 2, which means it's rad 3. And the sine of 60, so now that's going to be rad 3 over 2. Notice the sine of 60 is the same as cosine 30. Cosine 60 is 1/2. Tangent 60, so opposite, so rad 3 over 2 divided by 1/2, which gives you rad 3. Cosecant 60, the reciprocal of rad 3 over 2 is 2 rad 3 over 3. The secant of 60 is 2. And the cotangent of 60 would be rad 3 over 3. So notice it's the same ratios that you got up here. So it goes just like with 45, 45, 90, with 30, 60, 90, whatever the sides are, the ratio for sine, cosine of 30, and sine, cosine of 60, and all them is going to be the same no matter what the sides are. So now let's do some examples here. Finding the tangent of theta. Well, remember, in order to do that, you need to know this side here. So you need to do the Pythagorean theorem. So x squared plus 24 squared equals 24 rad 2 squared. And when you do that in your calculator, you get x equals 24. So, to do the tangent of theta, you go opposite over adjacent. So it's going to be 24 over 24, which is 1. For sine theta here, you need to know the opposite. So you need to go 9 squared plus x squared equals 3 rad 13 squared. So you go 81 plus x squared equals equals 117. And then when you subtract, you get x squared equals 36. So x equals 6. So the sine is equal to 6 over 3 rad 13. When you reduce, you get 2 over rad 13. When you rationalize, you get 2 rad 13 over 13. Here, when you do the Pythagorean theorem, or you can realize since the legs are the same that this is going to be 20 rad 2, it's a 45, 45, 90. The secant, remember, is hypotenuse over adjacent, so it's 20 rad 2 over 20, which is equal to rad 2. And remember, that's consistent with what we did with a 45, 45, 90. The secant was always rad 2 there, so that's consistent with the fact that this is a 45, 45, 90. Here, you do the Pythagorean theorem. And when you do that, you get that x equals 9. So the cosecant, remember, is hypotenuse over opposite, so it's 15 over 9, which is 5/3. Whenever you're finding an angle, here, you set up the equation, so you know the opposite and adjacent, so you go tan theta equals 4.3 over 16. But remember from our word problems, to find the angle, we use the inverse button on our calculator. So we do tangent inverse. So on our calculator, we go second tangent, and then we go 4.3 divided by 16. Then we hit enter, and you get 15.04. And it says to round to nearest tenth, so in essence, it's equal to 15 degrees. Or 15.0, sorry, because you want to round to the 10th degrees. So for the next one, notice we have opposite and hypotenuse, so we go sine theta equals 7 over 15. So then theta is equal to sine inverse 7 over 15. So you go second function sine 7 divided by 15, and then you hit enter, and you get 27.81, so basically it's 27.8 degrees. There you go. So the last one here, you're going to find the measure of the missing side. So you're going to set up the trig ratio just like you did in the word problem. So here you have opposite and hypotenuse. So you go sine 61 equals 9 over x. Remember, you multiply by x. And then you divide by sine 61. And you get x equals 9 divided by sine 61, which is 10.3. I'll let you do the other one on your own just to see what it's talking about. When it says solve each triangle, that means that you're trying to find the missing side, which is AB, and the two angles, A and B. So you want to find the missing parts. That's what it means to solve each triangle. Find the missing parts. To find AB, you can do the Pythagorean theorem. Right? And when you do the Pythagorean theorem, you get 4.4. Now to find the angle, one of them you'd set up a trig function. To find A, we'll do tangent because we have opposite and adjacent. So then we just do tangent inverse. And you get 43.2 degrees. And then to find B, you can go 90 minus 43.2 because you know it has to be, these two have to add up to 90 since that's 90. And you get 46.8. So there you solved the triangle. You got that A is 43.2 degrees and B is 46.8 degrees. So go ahead and try the next one using the trigonometry, and you can check your answers on the website. All right, I hope you've enjoyed the video and have a good evening.